Here is my walkthrough of question 3 from last week's mechanics homework. It's the one about the bead on the inside of a hemispherical bowl. It's moving with velocity root rg, and it is 1/2 r above the base of the bowl. First thing you have to do is show that it just makes it to the top of the bowl. This is a straight energy calculation. All we do is this. At the start, the gravitational potential energy is that, 1/2 mgr. At the same time, the initial kinetic energy is also 1/2 mgr. Therefore, total energy is mgr. For it to reach the very top of the bowl at the other side, for it to end there, it has to gain GPE of mgr, which is exactly the amount of energy it has. Therefore, it just makes it to the top of the bowl. Done. Part 2 of the question is a little bit trickier because we have to consider the normal reaction of the bowl on the particle at a different point on the hemisphere. Therefore, we need to draw a new diagram. Now, the particle is situated 1/3 r above the very base of the bowl. And now we need to take into account both the velocity and the effect of the mass of the particle, which we will call m, giving the particle a weight of mg, and we can resolve that weight mg perpendicular to the rim of the bowl and parallel to the rim of the bowl. What we are looking at is the normal reaction of the bowl on the particle. Therefore, we need to consider this component here, which is simply mg cos theta. But look, we have a triangle here such that the adjacent side is 2/3 r and the hypotenuse is r. Cosine theta is simply adjacent over hypotenuse, which in this case is 2/3. So a bit of the normal reaction is that. But that is not the whole normal reaction, because the normal reaction is made up of 2 parts. There is the bit associated with the weight, but there is also a second part associated with the circular motion of the particle. So now we need to figure out what mv² over r is. Aha! Wait, we have already done some work on the energy of the particle. And the kinetic energy of the particle is simply 1/2 mv². Therefore, that component there is simply twice the kinetic energy. So what we need to do is figure out what the kinetic energy of the particle is at that point there. At the start of its motion, the total energy of the particle is mgr. We know that at this point it has GPE of 1/3 mgr. Therefore, the kinetic energy is 2/3 mgr. Therefore, double the kinetic energy is 4/3 mgr. So, we can rewrite this formula as 2/3 mg plus 2 times 2/3 mgr over r, and the r's simply cancel out, gives us a total of 2/3 plus 4/3, 6/3, 2 mg. That is the total normal reaction at this height.